It hasn't been, sorry.
I apologize for that. Well, I just clicked on it now. Sorry, sorry. Anyway, I'm recording it now. Again, yeah. To repeat, go to Brightspace. Sniffing lab. Okay, this is where we are this week. As you can see, some updates have been made to the seed labs. We always want to use the most current. So we're going to look at the sniffing link here. Okay, read through the other ones. They're usually the same, with a few changes. And what I would say is always take the newest one, because that's the one that has, a lot of the solution. Whenever this has like little bugs, this has the solutions to it. So I definitely recommend that you take a look at that. So now I'm going to open the document and just talk a little bit about what we're going to do. So all right. So this is the packet sniffing and spoofing lab. Okay. As you can see, we're just going to take a quick look at it. These are the tasks using sniffing tools. All right. We're going to take a look at scapy. So for those of you that have taken 372, I've talked about this a little bit. And so scapy is a tool in Python that helps you to create packets in a very efficient way, right? So we don't have to program these things in C and C++, which is a little bit more complex. And we'll be using scapy throughout the semester. So the first thing we probably want to do is we want to sniff packets, okay? So sniffing just means we're going to create a sniffer, a little program, and the program will grab the packets, break the packets into the individual headers, and then we're going to analyze data. So remember, this is what will allow us to get look at the individual parts of a packet, okay? So we can see that. So for instance, we're going to, sniff some packets. We're going to spoof ICMP packets, which are ping packets, right? And you can see it provides all the details here. We can look at also at individual commands, and then finally we're going to do sniffing and then spoofing, a combination of both. Now I may make a few changes to the lab. Okay, so I'll provide a few little different things that I will require you to do as well. As you can see here, there's also a way to do this in C and C++ with the Libpcap library. You can see the pcap right there. Don't worry so much about the C code. I've already, if you look in the folders, I've already provided the code for you. So you really just have to use it, okay? So that really will be the idea. Although if you have an interest in this, you can always read through the chapter in the book, and that will give you a lot more insight. Okay, so as you can see, it's basically that. We're going to do exercises on sniffing, the sniffing and spoofing, okay? And basically, we're going to try to do everything on here. So this will be a fairly extensive lab. It'll be a fairly extensive lab, but we should be able to get through it. Okay, I also want to look at the other document, the one I have posted. So this one, so I'm going to open it. Okay, you can see that here. Okay, and right now I'm just kind of giving you, how things, before I get into the formal description, I'm just pointing out everything. So you can see here, the problems that I'll ask you to work on are to, have a sniffer again, and answer some of the questions. As you can see here, you'll read through all the questions and try to answer them. And then we'll try to create, so when we do sniffing, for instance, the scenarios we want to address are, we want to capture ICMP packets between two specific hosts. So how do we do that? Then we want to capture TCP packets that have a destination port range from, port 10 to 100. Okay, so we also want to look at that. And then we want to maybe, if we use telnet, right? Telnet is an insecure version of SSH. So we also want to look at telnet and, you know, log in. So we're going to use telnet to log in remotely to another machine. The goal of this would be basically to steal a password, because the password that's going to be sent when you log in is not encrypted. So we're going to look at that as part of sniffex. Sniffex.c is the program that we're going to use also. This code is already written, so as I said, you really have to do very little except modifying the filter expressions. Later on, once we finish all the sniffing problems, we'll focus on spoofing more, and that's, as I said, if sniffing is kind of like defense, think of spoofing as attacking, creating fake packets, you know, either through scapy. I'll show you guys how to do this through scapy, and also how to do this through C++. They're both really using the same underlying code. It's just obviously Python is a little bit more user-friendly. All right, so we'll be doing this document also. All right, so as you can see then, sniffing, these two links are your homework assignment, okay, for the first week, or first couple of weeks, really. All right, let me go back to the seed projects, and let's just quickly, I just want to see how different this new, okay, so here you can see it's pretty much the same layout, network security. Now I'm in lab 2.0, and you can see they have the same labs. I can't imagine that they completely changed these labs. And I'm going to click on sniffing for 2004. Let's look at the PDF. All right, so it seems it's the same code that I saw before. Same code. Sniffing packets. Sniffing packets. Spoofing looks pretty similar. Trace route, yeah, so I think it's the same lab. I think, honestly, the only difference that I've noticed in this, and I don't know if you guys saw it, is that at the beginning, it had something about Docker. So Docker is another solution to VMs, if you will. So if you'd like to, on your own time, the only thing I'm going to require is to do things via VMware, or that I'll cover. But if you guys, for those of you that like to, that have, you know, just want to play around with tools, take a look at doing this in Docker. It might be, I believe Docker is a little bit more friendly when it comes to RAM and the load on the computer. So you might want to take a look at that and see if you can do the labs with Docker as well, okay? But as far as the problems themselves, it seems that they're exactly the same ones, okay? Is this clear, guys? Are there any questions?
No questions.
Makes sense, right? So I know there's a lot of documents, but really it's really just, they provide too much help, I think, right? So a lot more materials to look at. All right, anyway, that's good. So that's kind of a description of what we have, the resources. When is this lab due? So that's a very good question. Remember what I said at the beginning of the semester. Think of this class as a work, you know, it's kind of a lab, a full lab, right? So you're just working on solving problems. So it's possible, because this is a long one, that it's going to be at least 2 weeks, okay? So I'm not going to assign a due date yet for it. Instead, I just want us to work through it. Okay? Got it. All right, great. So let's then now formally start the lab. So I'm going to switch over to Brightspace.
Professor.
Yeah, go ahead.
Yeah, I just have one more questions.
Go
When we
ahead.
submit the lab reports, how do you want the lab reports be?
So lab reports, usually I just need one lab report, a Word document or PDF. And as you've seen, a lot of these just have problems, right? You have problem 1, problem 2, do this task, answer these questions. So you need to provide the answers and you need to provide screenshots showing evidence that you have completed the task. Do you understand?
Yeah, I got it. Okay, thank you.
Right. Yeah, so usually just one document. Or like I said, some of these labs will require us to do demos. And so you'll have to do that as well. All right, so let's start with the lab here, the lab description. I'm going to start with sniffing. Okay. All right, so overview. Okay, so packet sniffing and spoofing are two important concepts in network security. They are two major threats in network communication. Being able to understand these two threats is essential for understanding security measures in networking. There are many packet sniffing and spoofing tools out there, as you know, Wireshark, TCP dump, NetWalks, and also just your own code like with Scapy and Python, or directly using the Libpcap library in C++. So we're going to explore all of these tools. That's really the goal of at the beginning of the semester. So some of these tools are widely used by security experts as well as by attackers. Being able to use these tools is important for students, but what is more important for students in a network security course is to understand how these tools work, right? And that's the reason why we don't just like have a GUI interface and press a button, right? You're gonna get into a little bit into the Python Scapy and even further deeper into the C++ code, although there won't be any C++ coding. So basically, how these tools work, how packet sniffing and spoofing are important in software. The objective of these labs this week is for students to master the technologies underlying most of the sniffing and spoofing tools. Students will play with some simple sniffer and spoofing programs, read their source code, modify them, and eventually gain an in-depth understanding of the technical aspects of these programs. Okay? And at the end of the lab, students should be able to write their own sniffing and spoofing programs, hopefully. So let's talk a little bit about writing. So how would that work? Writing a program. So, sorry. Writing packet sniffing programs. That's the first thing. So the underlying library for everything is the PCAP library. That's the first thing that you should know, right? So sniffer programs can be easily written using the PCAP library. With PCAP, the task of sniffers becomes just simply invoking a simple sequence of procedures in the PCAP library, again, to capture the packets, break the packet into the individual headers, and then from each header, extract the field. So you will see that, when I provide the code examples for you, how the code works, basically, right? You'll see that. But we won't always use that. We will always just, our preference will always be to either use like Linux commands or Python, okay? At the end of the sequence, packets will be put in a buffer for further processing as soon as they are captured. All the details of packet capturing are handled by the PCAP library. Tim Carstens, who's a famous person, has written a tutorial on how to use the PCAP library to write a sniffer program. So the tutorial is available at this URL. You can see that here. You can copy it, Control copy. And then I'm going to go to the website here. plug in that URL. All right. All right, so you can see I copied the URL and I just went to the website that it provides. So here, although I'm not saying that you have to say memorize all of this, take a read through it. Think of it as a reading assignment. So read through this whole code. It just provided us an explanation of how the Libpcap library works, okay? Remember, as I said, everything, Wireshark, everything, all those programs are built on top of this library. So it's very essential. And so by understanding this, the point is that you understand, okay, if somebody Cisco or whomever company builds a firewall, builds an IDS, they're going to start here, okay? They're going to start with these concepts before they build their own solutions. So this basically provides an explanation of how this works, and you should take it as a reading assignment to take a look at the details of it. Okay. At the end of it, though, one important thing is to click on this, right? So once you've read this, you can simply just use the program, simply download sniffex.c and try it out, right? So you see that there? You see this link? Right? So click on sniffex.c. So that's the first thing you'll have to do in lab. So maybe take your notebook or whatever and write down, to do this lab, step number 1, go to this website, download sniffex.c. Okay? Once you've downloaded sniffex.c, step number 2, you need to compile it, right? So you call the GCC compiler, compile it. I will provide in a second, later today, I will go into the whiteboard and I'll write down some of the commands that you might need for that. But for now, I'm just kind of giving a big picture. So why do we need sniffex? Sniffex is the little program that we're going to use once we make it an executable to sniff. Our very first sniffer should be based on the PCAP library. So the great thing about sniffex, though, is that it will have, you don't have to modify too much of it, right? You don't have to modify too much of it. You can go and take a look at the code, but there's going to be somewhere in the code a setting called the filter expression. So I'm trying to find that here. There it is, I found it. So hopefully it's very clear, so hopefully you guys can see it. But if you go here, you'll see right here where I just highlighted where it says port 23. In your code, if you notice, in the int main of that file, right, you're going to go to that file, and in the main, you're going to find filter expression right there. And now you can see that this is very similar to the way you write things in Wireshark. So if you remember from your 372, where you did a whole bunch of Wireshark readings, you might remember that you can write here filter expressions. So for instance, port 23, right? So you're looking for packets that have a port 23, or you're going to specify more details about IP numbers, protocols, etc. That's really what we will be doing all semester. We're going to be looking at ways of writing these things to get, at the end of the day, even though it might change, you will know in your own head, well, you know what, they're all consistent because first of all, they're all kind of based on that PCAP library anyway, right? Libpcap in C. So they all really have to find, there's a common theme that all of them have. It's like, you might have all the, like all these cars, right? But all these cars really just use a Ford motor, right? That, they have one specific, or a Mercedes motor. They use just, the underlying, under the hood is the same over, or now with electric cars, right? Like Tesla might sell their technology to others. They just make the body, but the underlying, under the hood is their technology. So it's similar idea. So that's what the lab will be about. So now that you know, step 1, you download that sniffex file. Step 2, GCC, compile it, make it into executable. Obviously, every time that you change this filter, you have to compile it again. So I'm sure you know that. All right, so now that I've pointed this out, you know where to find the code and you know where to make the change. Now we can switch back to the document that we were reading. All right, here we go. So now that you have that, you've gone to the website. So in this task, you need to read the tutorial, play with the program sniffex included in the tutorial, read the source code, sniffex.c, and now you're ready to solve the following problems. So for this week, you know, starting like now, like I said, I'm not assigning it yet, so it's not due next Thursday. Instead, I just want you to start. Let's take it easy. Let's get everyone comfortable. But basically, I want you to start solving these problems. 1, 2, 3, 4, and 5. Okay, that's all I want you to work on right now. You don't have to worry about spoofing yet. I will address that in another talk, right? When it'll be another video. But as far as the homework, starting the homework, I just want you to focus on these 5 problems. So what are the 5 problems that you have to answer? By the way, I would recommend that you answer problems 1, 2, and 3 initially. Just, you know, guess what they are. Okay, kind of make a quick read through it and then say to yourself, well, I think because of this and that. Then do 4 and 5. And once you've completed 4 and 5, go back again and re-answer 1, 2, and 3 and explore if your intuition about the network and network security was correct. All right, so problem number 1, what is it that you have to do? Please use your own words to describe the sequence of the library calls that are essential for sniffer programs. This is meant to be a summary, not a detailed explanation like the one in the tutorial. So what do you have to do for this one? Read the tutorial, okay? And then just in less than half a page, right? So less than a page, half a page, just in your own words, describe your understanding of the code and what it's doing, okay? Then problem number 2, why do you need the root privilege to run sniffex? Think about that. Try to answer it before, then run the problems, then go back and see where does the program fail if executed without the root privilege? So remember that. So everyone should have taken 372 at this point. So you know what root privilege and sudo and all that is. All right, problem number 3. Please turn on and turn off the promiscuous mode in the sniffer program. Can you demonstrate the difference when this mode is on and off? Please describe how you demonstrate this. All right, so this is something that actually will come up several times in the semester, right, in some of the labs. Some will work strangely. This is one of those things where, it's not doing what it's supposed to be doing, but it might be because of this. So you'll have to, look this up, look up the concept, which I'm sure you've covered already in 270, and then try to answer this question as it relates to the lab. Okay, those are kind of just more theoretical types of questions. Then after that, you will take a look at problem number 4. In problem number 4, this is where you actually go into the sniffex.c file, and you have to make a few changes. So please write a filter expression to capture each of the following. In your lab reports, you need to include screenshots, as I said, to show the results of applying each of these filters. So basically, I want you to write a filter that can capture ICMP packets between 2 specific hosts. Okay, so what do you have to do there? What's the test case? So who can tell me? What would you have to do to show evidence that you completed this task? What do you need? So capture the ICMP packets only between 2 specific hosts. What do you think? Guys? Anyone? Okay. Let's see. Yeah, so you have to create a scenario, right? You'll need to have two computers, A and B. One computer is going to do ping, right? That ICMP packets or ping packets, and then it's going to ping, some other machine, right? That's basically ping between two computers. Exactly. Very good. Ping between two computers. But you also have to have something in between, right? That's going to be the sniffer, right? That's the idea. You need to configure that idea. Now, this will work with just one machine, obviously. You could try two machines as well. So one machine can be pinging. The other machine could be the one that just does the sniffing, okay? And so you have, now this is where you're gonna have to start thinking about, if you have at home, two laptops, for instance, this is actually a recommendation I would give you. If you have a computer at home and a laptop, or two laptops even, these labs would be done, you would get a little bit more out of them. And also if you have a switch, if you have, you have maybe an old router at home, one of those Linksys maybe, where they have a little switch in the back, that would be a perfect thing, because you can just turn it on and then connect both your laptops to two ports in that switch, and now you have two computers in a switched network. All right, and so a lot of the labs, if you can do that physically, you might want to do that. Otherwise, you can also do it with a virtual machine. So that's perfectly fine. But that's a suggestion that I have. At the end of the day, what we want, though, and I'm going to switch now to the whiteboard, is we want to build the following, right? So we want to have, we would want to have, in theory, a switch with two ports, maybe four ports, and then you have one computer. You have one computer, PC1, and then another computer, PC2. Okay. So the idea right now is that you're going to sniff the traffic somehow. We in the lab actually have what is called a network tap, which is a little device where we have port mirroring. And so the great thing about that is that with that device, we can mirror two ports. So we could mirror, let's say, these two ports, right? And so we could connect to this one a listening device, right? The sniffer. Okay, so we could connect the sniffer, and that way, whenever PC1 sends a packet, right, destined for PC2, right, any traffic that goes through here through a network tap gets mirrored into this. And so the sniffing machine can also take a look at it. You can try whatever device that you want, okay? You can try whatever device that you want. Also, you can do these virtually, but what I'm saying is usually in our lab, our physical setup, we have this device, the network tap. And so it just makes it a lot easier for everything to be physically connected. Okay, so here, we're doing things virtually, so we'll have to adapt a little. You want to work as a group. That's another question. How can you work as a group with the pandemic? You mean like remotely? Is that what you're telling me? Yes, let's do that actually, guys. Okay. Do you guys want to work in groups? Guys? Can you even do that? I would like to, yeah. What do you guys think? Yeah, let's do that. So whoever wants, some of you don't want to work in groups. Okay, yeah, I can't make this I don't know, that's a good question actually. Because of the pandemic, I'm not sure that would work. for now, do things individually, okay? As best as possible. You can talk amongst yourselves and, you know, help each other out. But as far as submitting reports and everything, do everything individual, okay? Sorry, it's just I don't really know how to set groups here. Okay, so the basic intuition with this lab is that you would want to do something like this, right? So PC1 sends a packet. The packet arrives at PC2, right? And then you'd have a mirrored port, you know, like with a network tap. And so the whatever passes through this port is also mirrored on here. And so the sniffer basically can look at the packet as well, right? It just looks at it. And that's where that idea of the promiscuous mode comes in. So you'll have to do a little bit more research on it to understand that that's pretty important. However, with the VM, you know, now if you just think of doing this in the VM technically is connected to a network, right? It's connected, let's say, to the hardware machine, the Windows machine. So you can always just have the sniffer as running on one terminal and then have another terminal for the ping. Do you see that? So you can have a sniffer, you can have the ping. And so when you start sending out packets, ping packets, right? You set the sniffer to sniff anything in the network. It'll sniff the packets that are leaving. And so it'll be able to capture them. And really what you have to do is just set up the filter expression correctly. Does this make sense, guys?
Yes, it makes sense.
Okay, great. All right, so that's, you know, I'm trying to give you the big picture of it, but a lot of this can be simplified in, you know, in the lab. All right, so now now that was the first problem. Second problem, you should be seeing the PDF. Second problem is capture the TCP packets that have a destination port range of 10 to 100, right? So now keep in mind, remember, a packet has an Ethernet header, an IP header, and then it's either an ICMP, UDP, TCP, right? Those are usually the packets that we're going to be covering in this class. And so that's basically the protocol. TCP, I think, is protocol 6. So you'll have to then capture only only TCP packets that have a destination range from 10 to 100. So how can you test that? Well, you could test that if you use SSH, port 22, port 80, web, right? So you'll have to maybe set up that same idea. So how can you trigger port 22 or port 80? Open a browser. If you open a browser and you try to navigate to some website, that'll generate TCP packets with a destination port of port 80. If you do SSH, port 22, or you can do telnet, that's another one. So you can try all of those. Got it? All right, so that's what you have to do on that one. And then the last one will be problem 5. Please show how you can use sniffex to capture the password when somebody is using telnet on the network that you are monitoring. Right, so usually you don't want to use telnet because it's not encrypted; it's in clear text. So what you want to simulate here is capturing the password. You may need to modify the sniffex code a little bit in this one. You also need to start a telnet server on your VM. Okay, so telnet, and it provides here some information on how to do that on 16.04. Or the telnet, I think it's already installed. So if that's the case, then just run this command to start it. All right, that's it. That's all I want you to do for now. Remember, this is just getting you into it. All right, so I'm not really going to ask for more. On Monday, I will give more instructions on and explain other things. But let's take a look at 5 and what I expect. So I'm going to switch back to the whiteboard. Okay, and what we're going to try to do on number 5. So it's saying there, again, you'd have 2 computers, computer 1, computer 2, 1. So telnet, as you know, we'll be doing a lot of tunneling this semester, right? So tunnels are connecting between computers, sending data, encrypted tunnels, unencrypted tunnels, all that. So the idea is you have a port, and then they're connected, right? From computer 1 to computer 2. We need to have a service like SSH, but in this case, SSH is encrypted, so you will not be able to capture the password, right? Instead, you will use telnet. So you need to start that service. Let's say this. So this becomes a telnet server. And then therefore this becomes a telnet client. Okay, so then you're going to have to start the client, right? And try to connect to that. Right, so that means, telnet and the IP address. So this is, 192.168.1.5. This is 192.168.1.7, whatever it is. All right, and so you're going to initiate, so the command line, telnet 192.168.1.5. Okay, you're connecting from in this direction. Okay, when you do that, it's going to ask you the login, right? So you're going to enter the user. So if you're using the CDM, for instance, it's user and tour. Oh, sorry, no, it's not user and tour, is it? It's seed and Ds. That's what it is. Seed and Ds, right? So those are the username and password usually. Now the key thing is, you're going to also open a terminal. So you have 2 terminals, one for the telnet connection and a second one for the sniffex program. You change the filter expression to capture telnet connections, right? Think about the port number, the destination port. Is it a TCP, UDP? Start thinking about those little things. And I'm sure you know it, but just start thinking about it. So sniffex is going to be running on here. And all you have to do is you have to capture the password. So you're going to enter first seed, then you're going to enter Ds, and so on. Now, usually the code that you have in sniffex, I think, has a minimum of 10 packets. It only captures 10 packets. However, this exchange, until you're logged in via telnet, takes more than 10 packets. So the change that you'll have to make is that you'll have to increase this. If you increase it to like 100 packets, you should have enough data in there that it'll capture all 100 packets of the exchange. Because telnet is encrypted, you will see this. Usually telnet sends 1 character at a time, so it'll kind of list it as DEES. So your output will look like DEES. All right, and that's it. That's all you have to do for these problems. All right. So as I said, I just want you guys to kind of get started with it, and then after that, on Tuesday, I will give you more details on the next questions that I want you to address. But try, although this is not due Tuesday, I would recommend that by Tuesday you've solved these problems, and definitely ask questions if you're stuck, because that's sort of how I will go this semester, right? So I'll assign something, and then on Tuesday we move to the next, and it's going to build up. Everything this semester is very sequential, and everything builds on, literally most of the semester, everything builds on the previous ideas. So don't fall behind. Okay, so that's sort of the intro for today, just getting everyone caught up. What else? To make it easy for you, I will give you some ideas. We still have a few minutes. give you some ideas of the filter expressions. Okay, the intention is not to, make it too difficult. So some of the filter expressions. So in that C++ filter expression, right? So ICMP, oops, you can literally just write the protocols in there like ICMP, right? If you want to maybe say and, you can type and, right? And then you can use parentheses to indicate. So you can say, for instance, ICMP and source or destination equal host, and then let's just say 192.168.25.1. I'm just making up numbers, 130. You see that? This is for IPs. So source and destination IP. Okay, so that expression is looking at the header for ICMP, for the protocol. It's looking at the IP header. It looks at the protocol for ICMP. I can't remember. I think it's like 1 or 2 for ICMP. And then it looks at the IP, source and destination host. And also, if you want to make it even more complex, you could say and source or destination host, and then just some other host. Let's say you want to limit it to a couple of hosts. 131, right? And you can see that. This is usually in double quotes in the filter expression. And that's it. That's really all you have to change. Okay, guys? Let's say that you wanted to capture, port numbers, right? So if you want to do some port numbers, filter expression, let's say you specify that you want TCP, where destination port range, and you can specify a range. You see that? And so that should be a pretty good approach. So basically you change the expression, you compile the code again, you start it, and then it's just going to sit there. When you initiate the communication, whether you start the telnet session or whatever, that's when it'll start capturing packets. And just remember, by default, I think it captures 10. So you might need to increase it. Okay. And of course, there's a lot more that you can do with the filter expressions, but these are just some examples to get you started. All right. So as you probably know, you cannot really, with programs, set the parameters of a packet, right? So to set the parameters of a packet, basically to spoof a packet or create a packet, you have to take over the network card and then use code to kind of build it. But that's something that I will show you when we get to the spoofing lab, okay? The spoofing part of, not spoofing lab, spoofing part of this. All right, let me see what else you might need for this. So remember, you should start working on all of this and try to have it complete by Tuesday, because that way we can start the next section. All right, to compile, if you don't remember how to compile a program, let's assume that you're on the terminal, and then you have the sniffex.c file already downloaded, right? So then all you have to do to compile is you do gcc sniffex.c, and then you need to include usually the Libpcap file. Okay, so you'll need to include that there. I can't remember if this is, I think that's uppercase, but just try both. It's either lowercase or uppercase. But this is a flag, and basically we're including the libpcap and then just the output. And then you can call it sniffex. So once you've done this, you need to answer the question, do you run sniffex like that? Or do you run sudo sniffex? And if so, why? Right? So that's one of the questions on there. You have to think about that one a little bit. Okay, so for today, that's pretty much it for today. As I said, today is just barely getting into it, kind of playing around with the VMs. So make sure you get your VMs ready to go, and make sure you get your start working on that lab. On Monday, I will. Oh, sorry, Tuesday. Let me switch back to right space. On Tuesday, I will come back to the slides, right? So we've completed these slides here, but I will come back to some of this on Tuesday, the lecture, and then we'll move on to the next part of the lab, which will be, you know, what's in this link, okay? And, you know, of course, covering a little bit of what's in here. But that's it for today, okay? Hopefully that makes sense, how to get started. We can stop here for today, and I'll stay for a few minutes if you have any questions. Otherwise, I'm going to, at this point, sorry I missed some of the recording in the beginning, but at least we got some of it. All right, so I'm going to pause the recording now, as I'm not going to provide any content, but you can stay if you have any additional questions. Otherwise, have a good weekend.